Welcome back from lunch, everyone. Let's wait for a few minutes. I am assuming that it's still slightly early. We're gonna start at around 2:01. Yeah. Okay. Can you post what you have lunch for? What kind of food you have for lunch in the post in the Q&A for fun? I think it's a good way for you to also practicing your Q&A as well. These are very important features on a webinar. Post something in the Q&A. What do you have for lunch? How much you rating for that lunch? Is it 10 out of 10 or the 8 out of 10? Or maybe it's just maybe 2 out of 10 in the Q&A. Okay, let's start in maybe 1 or 2 more minutes, then we're gonna start. Okay, so maybe before we start, I think I will take maybe 1 or 2 minutes, just briefly remind you guys about all the workshop topics again today and tomorrow. So this afternoon, we're gonna go through the workshop about machine learning at 2 p.m. To 5 p.m. And then tomorrow, we're gonna learn about cybersecurity. Specifically, you're gonna be get undercover to uncover hacker task static, and then you try to learn more about cybersecurity, hacking stuff, right? Which is really fun. Cybercrime here, right? Very cool. And then in the afternoon, tomorrow, you're gonna learn about Arduino and the embedded system. It's really fun. You're gonna build your own traffic light system. Okay. Keep in mind that we have 1, 2, 3, 4. Right? We have 4 different topics, and we will have 4 different topics for the project. Right. So each project description and topic will be allowed one of the workshop topic. Right. So you are feel free, your team will feel free to selecting any topic that you like, right, very much for your project, and you can work on that topic, okay? So if someone care a lot about Gen AI, you want to do some cool vibe coding, right, you're choosing topic 1. If you really love machine learning, you want to learn more about different kind of machine learnings, right? Then go to topic 2 for the projects. If you love cybersecurity, then go to topic 4. But if you love embedded system, right, you want to get your hands on some of the virtual electronic system, then you go for topic 4. Okay, so we have 4 different topics, and we don't expect everyone to be in love with all 4 topics, right? So if you have 1 or 2 topics you are really passionate about, just go for the topic. All right, so it's actually now 2:02 now. I think we can start now. All right, let me go on to slide. All right. Welcome back from lunch, everyone, and I hope that you are already filled up, stretched out, and ready to go. because this afternoon section gonna blow your mind. Okay, we are going straight into the world of machine learning, and you heard the buzzword of machine learning everywhere. It's the magic behind the TikTok algorithm. It's how your Spotify know exactly what song you want to hear next. It's the brand inside the self-driving car. So this afternoon workshop name gonna be "You Teach the Machine Learn." I sound very cool. To guide you throughout the journey, we have two absolute rock star, AI rock star from RMIT of Vietnam. First up, we have Dr. Tung Chung. He got a PhD in jazz in Japan, and his research is all about how human brain and digital environment interact. He's a master of taking complex typical concept and make them super easy to learn and fun to understand. And joining him, we have Dr. Wang Chung with an over decade of teaching experience. He's our guru, go-to guru for AI and programming. He's gonna help to bridge you between the gap between the cool AI theory and actual hands-on skill that you need to be intelligent system. Before I hand over, make sure you have the Orange data mining software download and open on your computer. And you haven't done that, please quickly go into this link here, orangedatamining.com here, and get that installed. Right. All right. So let's get ready to learn. And Dr. Tung and Dr. Wang, please go ahead and take over for the workshop. Thank you.
Thank you, Tom. So now I would like to share the screen. So firstly, thank you, Tom, for your introductions that I'm trying my best to live up to. So I'm not deserved to say that I'm just a lecturer at RMIT, and we are happy to have you all here to join us in the workshops. And together we explore just a brief introductions to machine learning. And I hope that after today's workshops, you see that machine learning is very close to our everyday life, and all of us can apply machine learning right now in order to support our life. Firstly, let me share the screen. So do you see the screen share? Okay. So firstly, Dr. Wang will go with you through the agendas and the introductions to today's topics and some setups to prepare for the topics for today. And then I will work with you through the steps to use one specific tools in order to implement the machine learning projects. So over to you, Dr. Wang.
Yeah, thanks, Dr. Tuấn. Thanks, Tom, for your introduction. So in today's workshop, we have 4 items, and you can see the timeline here. The first one is the introduction, and also we spend some time for the student who have not finished download and set up the software. It's very easy, everyone, but it's take a little bit of time. I really hope that after this 50 minutes, then most of you will be ready. And after that, we will have a demo sections by Dr. Tung about machine learning projects, the simplified one to get you a feeling of how you can get the data and let the machine learn from that data. And then you will have the thing that we call the train model. And after that, I think that's the most interesting part in this one is it's your turn. So we have about 55 minutes for you to practice mixing with the Q&A and anything pop from your mind, and we are here to support. So in the practice one, you will have your own data set, and then you work on that, you build your own model, test your model, and after that, we'll wrap up in Q&A. Yeah, Dr. Tung. Yeah, okay, so the first one, instruction and software setup. So this is a very simple example about the concept of machine learning. So in machine learning, we have the 2 terms, right? Machine and learning. And it basically answers the questions. So can we train a computer to make any types of decision from simple everyday one to very complex decision? And we can on them with that with modern machine learning. And here's some example like some everyday tasks like will I be late to school, and it can be applied machine learning to a task that's called classifications. The next one, we have like shoot a umbrella, so we predict the weather. Okay, that's also achieved on classifications. And the last one, how many minutes may the homework take for you to do. Okay, so then this one is the task is called regressions. And for each type of task, one very important thing is to define the target. We will go to the detail of that later. Okay, so in machine learning nowadays, the most important part we believe is the data set. Okay, so actually in machine learning, we have two parts, the data and the algorithm. Nowadays, I really believe that most of the algorithm out there, they are quite mature and they are available there. You can go to GitHub and thousands of them available there for you. They are open source, they're very good, they're excellent. So what makes your projects, what makes your company, if you have one in future, stand out from the others is the dataset. Okay, so dataset is the most important part of machine learning nowadays. And so what is the dataset? We have many types of data, and what you're looking at in product use is we call that the tabular data. That is the data we put in the form of the table. So we have many rows and many columns. We will go into detail to tell you what is the terminology when we work with the table machine learning. We don't call it column, we don't call it rows, we call features and ensemble. We will talk about that very soon in the next few slides. Okay, so before we go into the detail, for working on the real machine project, we need a tool. A tool is very important. And out there nowadays, we have so many tools. And in this workshop, we select the tool that's called Orange Data Mining. And it is, the open source, but it's very good. Many people, they use it for their actual projects, not just for learning. Okay. So in order to get started with this one, so every student here, I believe that you can see the links already shared here. Or Dr. Trung, I think that we cannot click on this one.
Yeah, let me share the link on the Q&A.
Okay, so let's wait for the link. So the student, if you have not get the tool, the Orange tool, so now it's a time for you. We will leave you a few minutes to do that. Okay, so when you see the links, you click on the link and you will see two options. The first option is called installer. You download the installer and then you go through the installation process and then you will install a copy of Orange in your machines. So that's one option. The second option is you download the thing that's called the portable version of Orange and you don't need to download anything. Sorry, you don't need to install anything. You just download the things, unzip it, extract it into the folder you want to, and then there is a file called that is the executable file in Windows machine, and for Mac you have a similar file. You just click on that and you can run it. Okay, so
so let us spend 1 or 2 minutes to download and then install the Orange data mining tools. And when you have finished, could you put a thumbs up or a heart in order to let us know that you are ready, and then we continue. Okay, thank you.
That's good. Oh, great. Okay, let's wait just a few minutes for our students who have not a chance. Okay, so the link is there. So if you have not downloaded, the link is on the Q&A section. You can see the link there. And right under that, there is another link for the data set by Dr. Trung. I will also copy it to the related Q&A for your convenience. Okay, so the second link I just paused in the under the Dr. Trung post. That's it, the dataset for our first demo. You will use it in next few minutes.
All right, so while you are downloading and installing the application, so Dr. Wang will continue to show you the overalls of machine learning projects, particularly the key phases of machine learning projects.
Okay, thank you, Dr. Trung. So before we start, I would like to have a quick questions. So raise your hands if you can raise your hand, you can react with the thumbs up if you already did some machine learning project before. I just want to know. Okay, none of you. Okay, so now another one. So raise your hands or thumbs up if you have know about machine learning project before. Just know about them. Okay, I can see, okay, a lot. Okay, so at least you know about machine learning project before. That's very good. Excellent, everyone. So machine learning project is actually the type of software project, but is specified in the AI field. And in machine learning projects, we have some distinct steps. And you can see on the screen now is the key phases of a machine learning project. Of course, this is a simplified one. The full pipeline for the actual real one, it contains other steps, but here we show you the key step. So the step number one, so in my opinion, the first half of the key phases you see here, that is the phase number one and phase number two are the most important because this belongs to dealing with the data. Okay, so like I told you, data is the most important part here. So the step number one, or the phase number one and the phase number two is about the data. And the phase number three and number four is about the model. Okay, so the first half is very important. If your project, can go through the first half of the project like this one, I think you make like a good move. Okay, it's very promising if you can done well at the first one. So the phase number one is about getting the overview of your project, understand the problem. Without this one, it's like you try to drive, but you don't know where to go. Okay, so the first step is very important to understand clearly about your problem. And in this one, we have several things to clarify, but a few things very important we would like to mention is the first one. What is your end goal? It's not what is the goal, but it is the end goal. Let's say someone asks you to do some machine project about housing price prediction. Okay, but that's just the goal. That's not the end goal. So you need to again ask back to them, like you ask your customer or the one who gave you the project. So you want to predict the housing price for what? This is for the investment game, a simulation game, or it's for some real world trading software. Okay, so housing price predictions for game is very different from housing price prediction for real world trading software. Okay, so you should need to make clear that first point, because for example, in the just for game, then the performance of the model, we can say it here like the goodness of the model, how it's performed. It's the performance will be different from the real world one, even they work on the same task. Okay, so that's the first thing. You need to make sure you understand what you are going to do. What is your end goal here? So the next one, when you have the target, the next thing is to look around. Yeah, that's still in the previous slide, Dr. Trung. Yeah, thank you. So the second question is about, are there any existing solution? Yeah, that's one. Okay, so you look around to see if in the market or on the GitHub or and the Hugging Face or anywhere there is some any existing solution. Sometimes you have some open source, very good one. You can use them out of the box, or you can just improve that. You can just find the model, and then you can have your own solution. Otherwise, you need to make your model from scratch. But in my opinion, I believe that most of the project nowadays, we don't need to do something really from scratch. You should look around, and then you can find some similar project or some components that you can reuse in your project. So that's the second thing. We need to look around to see the existing solution. And after that, when we clearly understand about the code, we know about the existing solution, then we go into the data. Okay, we need to know where we can find the data. Is that provided by your customer, or is that you need to define by yourself? You need to find somewhere, or you need to collect it? We need to buy it. Okay, so that's about the data, and you can only tell which types of data I need to get after you answer the first questions. Okay, so that's about the phase number one. And now from the phase number two, we will have some hands-on activities. And of that, now you have the orders like open on your machine to be ready with the instruction by Dr. Trung for your some practice optional project. Thank you. And now,
thank you, Dr. Wang. And friends, so I would like to check if you have the orange data mining tools ready. All right, so as Dr. Wang has mentioned several times, dataset is one of the most important things for machine learning. And at the end of today's workshops, we will go back to the reason why a dataset is important. And I would like you to keep in mind the keyword that we have repeated so far, machine learning. And at the end of this workshops, I would like to ask you the questions. What is machine learning? All right, so now let us go to phase two to prepare the data. So in phase one, we have identified the end goal of machine learning projects or programs that we are building. And in phase two, we jumped into one of the essential parts, so preparing the data. And in this phase two, there are 3 steps that we will do in order to have a good preparation for the data. Firstly, find data sets, then explore the data into the data sets, and then done some process or pre-processing on the data so that our data is ready for the machine learning models to learn and to produce useful applications. For the first steps, find data sets. So recently, you can find data sets on the varieties of sources. For example, internet is one source for us to find data sets, or we can collect our own data sets. We can do some research and then accumulate data that suit our needs in order to answer the end goals that we have raised, and then we can build the data set from there. And we can also be given the data sets from our colleagues or friends or research communities or universities. And we use those data sets in order to build some useful applications. All right, so for the, given that we have found the data sets, the next steps we do is to explore the data. And so as Dr. Wang have shared with you, when you look at the data set, so data set is a technical term in machine learning, but in our everyday language, data set is presented in the form of tables, as you have seen, in the forms of columns and rows. And from which data sets, we need to explore the data inside that. Particularly, we need to identify the labels or the columns that we would like to predict, or the answers to the end goal that we would like to explore. And then we'll look at the rows of the data set. So in machine learning, the row is called the samples. And those rows are represented by features, which we call the the rows are represented by columns which return the features. And later on, we will explore further about that. Okay, so now let us go back to the first step. So let's say now we find the data. And luckily, so here we have a data set. So before we move on, I would like you to open the data sets that share with you, so you can find the data sets here in this link, or you can look at the Q&A. So the link is provided to you in the Q&A. Okay. Now, when you open the data sets, this is what you have seen. I give you a couple of seconds to take a look at the data sets. And this data set is about whether we can be late for school on a specific days according to some conditions. So this is the history of our being late or not being late for school. So I would like you to take a look at this for a while. Dr. Wang, would you like to add anything?
No, Dr. Trung, for now.
All right, so this is the data sets that we are looking for. And for these demonstrations, the end goals that Dr. Wang has shared with us is this. So we would like to build an application that looks into the history data and tell us whether we are likely to be late for school on the specific days in the week. And as you see here, we have a data set, and these data sets have a collections of columns. So let us count together how many columns we have in this data set. We have 1, 2, 3, 4, 5, 6, 7, and 8 columns. And if you open the data sets, we have around 60 rows in this data set. So if you look at this data set, it tells us the day of the week that we are going to school, the wake up times, the times that we often wake up in the history data. For school day, for example, on Mondays, we usually wake up at 7:10 a.m., 6:40, 6:55 a.m., 7:20 a.m., etc. And the next column, travel minutes, is the minutes it takes for us to travel from home to school. And then the weather, so on the day that we travel to school, whether it was rainy or sunny or cloudy, and then the traffic conditions of the day we went to school, for example, whether that day the traffic was heavy or medium or light, and then whether that day we slept late or not, and then whether we have prepared the bag or not, and given such conditions, then we'll look at the end result, whether we're late for school. Okay, and now this is the history data. So this data recorded what happened before the current times. So now at the present time, we would like to predict whether on Mondays with a certain condition we are late for school, or whether we not be late for school. So that if you can make some predictions, so you can prepare yourself better, so that given a certain conditions that maybe it tells us we are likely to be late for school, so we better prepare so that we will get to school on time. All right, so for now, are you clear of the end goal of the machine learning model we are building? Could you raise a thumbs up or hearts? Okay, very good. Thank you, friends, for confirming. All right, so okay, during the workshops, if you have anything unclear, feel free to post on the chats. So in this workshop, we have several friends at RMIT. So they are students at RMIT and the volunteers, and they will help you to understand the workshop more and help you to get the most of the workshops. And for the volunteers, thank you very much for spending time with us in this today workshops and the followings. Thank you very much. Okay, let's continue. All right, so now given we have the data set, so now let us use the tools, particularly the orange data minings, to process these data sets. Now I would like to open the orange tools. So this is the tools that you have installed. All right, so have you seen the screen share of the tool there? And is this identical to the tools you have on your machine, on your computer right now? All right, so let me walk you through this tool first. So this one is called Orange Data Mining, and this is a very powerful tool that help us to build machine learning model without need for much coding. And actually, when you use this tool, you can build very powerful machine learning, and it can serve us in multiple discipline in life, from everyday machine learning models to expertise or scientific machine learning models. Okay, and you see the user interface of this tool is very intuitive, very easy to learn. On the left-hand side, you see collections of icons of tools there. And in this tool, it is called widgets, W-I-D-G-E-T, widgets. So each of the tools here is widgets. And those widgets are grouped together to provide the categories of function. For example, these widgets help us to handle data. These widgets are used to transform data from one form to another, and these widgets are used to visualize data, to present data in graphs or diagrams so that we can catch the data in a different perspectives. And next, these tools inside of the model the model categories here help us to choose specific machine learning models which we want to use to process the data. The tools right below it, evaluate, is used to evaluate the accuracies of the machine learning model. Okay, so these categories are arranged in the order by which we perform we build a machine learning model. Actually, it follows the 4 phases that Dr. Wang have shared with you. Okay. All right. So now let's back to the slide here. So now, given we have the data, so the first step is to load the data into the tools. So there are several steps to do so. Firstly, you look at the data category widgets. After that, you choose the file widgets. And then when you click on the file, you will see a file which is added to the canvas, to the canvas, to the orange canvas. Okay. After that, you will click the file widgets to choose the specific file. And after that, you will see the contents of the file shown to you. Okay, so now let us do it together. Right, so firstly, let us look at the file widgets here. Click here and then you will see the file widgets. Click on the file widgets. You will see the file widgets showing here. All right. Now, I would like you to click on the file here. Double click. And then you will see a Windows open. Underneath that window, you will see the options for you to choose the file. Okay, so in this case, now I would like you to choose the URL because we will choose the file from the URL. Okay, and then let us copy the file. Let us copy the links to the file. This is the links to the file. You can find a link on the Q&A chats. Have you seen that? Hit us here and then click enters. Then down below here, you will see the structure of the files. Okay, so have you reached this step yet? Any difficulties, any problems? Feel free to share. All right, so here you will see a collections of columns. So it shows that your file is successfully recognized and loaded. Very good. Okay, so now let us go to the next steps to check the contents of the file. All right, so after this step, you have successfully loaded the data. So now let us go to the next steps. Next steps, let us view the data. Okay, in order to do so, we use another widgets. So in this case, we use the data table widgets, as you see here. Okay, and we follow the same routines. Firstly, locate the widgets, then click data tables to add the widgets to the canvas. And after you have clicked the data table, you will see the data table widgets appear on the canvas like this, right? The next step is to link between the file and the data table. It means that given that you have the data here, now we send the data from the file to the data table. Okay, in order to do so, you just simply click on the right edge of the file here and then drag to the left edge of the data table widgets. Click here and drag and drag to the left one. Okay, so let us do it together. Now, firstly, I click the data table. Then I have my data table, which is shows here. And then I go to the right edge of the file widgets. Click, drag it. And you will see the line connecting two widgets. Let me zoom in here. Okay. All right. So with that, let us continue. When you click dance, now your data is represented in the visible tables for us to see the data. Okay, so now let us go there and then double click on the data table right now. Double click here, you will see now your data is successfully loaded. Okay, so do you see the data there? So the data shows as we have seen in the snippet before. And actually, it provides us a little bit more summaries. For example, if you count manually, you will see there are 1, 2, 3, 4, 5, 6, 7, 8 columns. And then 1 to 60 rows, which means that you have 60 columns. And then you have 8 columns, sorry. And 60 rows or 60 samples. So each rows here is called a samples. Or in machine learning terminology, it is called a data point. So you can use these three words interchangeably, rows or samples or data points. And now when you look at the summary on the left-hand side, you will see brief descriptions. For example, here you see there are 60 instances, 60 rows here, 8 features, okay? No target variables, no meta attributes. So we will explore that a little bit more, okay? So right now we have finished one of the very basic but important steps. We see the data. Any questions so far? All right, so let us continue. So the next steps, given that you have the data loaded, so now let us explore the data a little bit more. So we have shared with you one of the most important thing in machine learning is data sets, and one of the most important step in about data set is to understand them, because if you can understand them, if you understand clearly, then you can see the structure, the features, the characteristics of the data, and from which you can build a very powerful machine learning model. All right, so let us explore the data. In computer science, in information technologies, when we say explore something, we do very simple step. For example, we count how many samples are there, and we have already done that. So there are 60 samples, right? Next steps, how many features are there? Okay, so here you see the new word showing features. And so in machine learning, each columns here, when structured, is called features. Okay, why we call it features? Because features in English refers to characteristics of something. So here, when you look at the data set, because in a computer world, we represent some entities, some real world objects in the forms of a table, as you see here. So we use the columns of the tables to represent the characteristics of the data given in this specific data sets. So this data set is about your daily routines to travel to school. So if you look at the columns here, this is the characteristics of a daily routine that you usually do to travel to school. Okay, so those are called the features. And if you look at this data sets from this moment, we can say simply there are 8 features in this data sets. Next, what does each rows represent? So you see here, we know that we have 60 rows or 60 samples. What does its row, what its row represent is routines of a specific days. Okay, so when you look at, for example, the first rows here, you can see that this is what you did in on some Mondays in the past. And when you look at the rows number 10, for example, so this is what you did on Tuesdays in the past. So each row represents what happening in the past. And when we look at the history of what happens, we can draw some conclusion from that, and we can draw some patterns, some habits, or some form, some patterns on that. And from that, you can use to predict the future. And next, what does each column represent? So as I've shared with you, each columns represents one characteristics of something happened in the past. All right, so far, any questions, friends? Dr. Wang, would you like to add anything?
Not now, Dr. Tung.
Okay.
I think you're excellent.
Okay, so in summaries, so although the data tables is very simple in structure, it is a collection of rows and columns, but actually it tells us something very important, particularly what the rows represent and what the columns represent. So each row is one past day traveling to school, and each column gives information about that specific date. And each row is called a sample, and each column is called a features. So the reason we provide you these terms, so that's after the workshop, you can learn more. And you can use these keywords, for example, sample and features, to search on the internet, or to use the AI. That's this morning, Dr. Lin has shared with you in order to self-study about machine learning. Okay, so keep that in mind. It rows here, samples, each columns, features. All right, so let us continue. Let us explore a little bit more. Now let us look at the columns. we have 8 columns here, and those columns are actually needs to be separated, needs to be divided into further categories. So actually we will divide the columns into 2 types. The first one is called labels. As you see here, you have the late columns here, and this late column is divided into the type targets or labels or class. Okay. And so what is a target or a label? So a target is an outcome we want the computer to predict. So if you look at this data set, you see that we would like to predict whether we would be late to school in a specific days, given the other informations. Okay, so late is the target. And the rest of the column is called features. So features are the input, and they are used for training the computers to predict the targets. So we use the features to predict the targets. That is why when you look at the data set, you look at the data set and divide that into 2 types of that. And other thing is that, so for a data set, there is no fixed columns for the targets or label only. It depends on the end goal that you have determined in the beginning. For example, in this specific data set and in this specific end goal, we would like to predict whether you are late for school. So that is why we choose late as a target. But in for this same data set, if you would like to predict other informations, you can choose other target. For example, if you look at the history data, you would like to predict whether the travel time is less than 30 minutes or more than 30 minutes. So in such case, maybe the travel minutes is the targets and the others are features. Okay, so for a given data set, you can flexibly choose the targets and the collections of features depending on the end goal that you have determined. Okay, so let us continue. Let's pass here. And now let us look at how we can use the orange in order to divide data into different types. Okay. So in order to do so, there is a typing mistakes here. Let me fix that quickly. All right, so in order to choose, in order to divide columns into types, we use another widget named select columns. The select columns as you see here. Okay, and when you choose the select column, then you can choose which column is a target, which columns are features. Okay, so let us do it together. Let's back to the orange here. So here you see that we done some transformation on the data. That is why you can choose, look at the transform here, and underneath you will see select columns. Okay. Now the other ways is that from the file here, you can click the right edge and then draw a line. And then from that, it will show you the corresponding widgets that goes with file. Okay, you can select columns here. All right. So are you following? Okay, select the columns and then double click on select columns. You will see a window. So here we will choose which features, which columns are features and which columns are targets. So recall in the previous line, we choose lay as a target. So you can draw, you can address the features from one place to another. Okay, so let's say here, my late features is here. So now I click and drag it into target. So it becomes the target. Okay, and the other features. So now out of 8 columns, I have 7 features and 1 target. All right. Okay, so let us continue. Now, let us look at the data after some transformations, after you have divided the columns into features and targets. So by now, I think that you are familiar with the routines of using orange. So now in order to look at the data, you can just simply draw a line from the selected columns to the data table. Okay, let us do it together. Now let's just draw a line from here, select the column, then draw it to the right-hand side, and then choose data table. Okay, and now click, double-click the data table. You will see now we have some more descriptions about our data table. Now, if you look at the data tables here, you see we have 2 separate types. The ones with the gray background and the one with the white background. And the one with the gray background is the targets. As you see here, the targets. And the rest are the features. And if you look at the brief descriptions on the left-hand side of this table, you will see that we have a summary. We have 60 rows, 7 features, and 1 target with 2 values, which means that our target has 2 values, whether it is yes or no, or whether we are late for school or not late for school. Okay. All right, so let us speed up a little bit. All right, so now you have reached a better understanding of your data set. But now, if you look at the data set, maybe it is very hard for us to predict which specific day we might be late for school and which day we might not be late for school. So it is better if you have a ways to separate your data in visual form. So some graphs or some diagram to show to understand the data better. So now we will look at the data, the same data, but in different forms. So particularly, we will explore the relationship between the features in order to understand the data more. And we have 2 types. We have many diagrams and graphs to understand that more. But for this data set, maybe I share with you just 2 types of data, 2 types of graphs or plots. The first one is called scatter plots. So have you ever heard of scatter plot before? So scatter plot is a diagram that shows the relationship between features in order to understand the data. And the second one is called the chart histogram. So it will show you the distributions of data on specific features. Okay, so now let us explore these 2. Let's just explore these 2 graphs. Okay. So now for the trap, in order to add the trap, we will go to the visualize categories here. Okay. So here you will see a scatter plot. let us click on the scatter plot. So the scatter plots will appear here. So in order to present the data in this scatter plot, just simply drag the lines from the data tables to the scatter plot. Okay, and then open that. All right, and now you will see the data in eye-catching way. Okay, so here you will see the relationships between the x-axis and the y-axis, and then the target the target columns, as you see here. So for the x-axis, we have the x-axis represent the wake up times, and the y-axis here represent the travel minutes, and we have the blue dot and the red dot. The blue dot represents the case of not being late to school, and the red dot represent the cases being late to school. And as you see here, for this you can answer the question, what the wake up times and travel minutes cause being late to school. Okay, for example, if you see here, if we wake up before 7 o'clock and the travel time is 35 minutes, so it is likely that we are not late to school. And if you wake up later than 7 o'clock and the travel time to school is more than 30 minutes, so it is likely that you will be late to school. So if you have this visualization, then it is very it is easier for us to make a prediction. So given that the wake up times and the travel time, then you can predict whether you are late to school, so that you can speed up or choose the shortest pattern to travel to school. Okay, so with that, you can have some information to which to build a machine learning model. Now let us look at other graph. For example, the distributions here, the histogram that I've shown to you. Now let us represent this data in distributions. All right, and here you see this is a distribution. This is a distributions about wake up times. As you see here, by distributions, you see most of the time we wake up at 6:55. Okay, and there are some times we wake up very late at 7:30. And we have quite of a good habit to wake up early at 6:25. And then with that, you can relate to the data set to see that what time zones and what wake up times here will likely to cause being late to school, so that we can you can remove that, or you can avoid that, so that you will be better to catch up school on time. Okay, so such such presentations will give us a variety of perspectives to look at the data, so that we can understand the data more. And so for generalizations in other machine learning data sets, you besides looking at the data by its number only, you can use some visualization like this to understand the data much more better. Okay, so any questions so far? Dr. Wang would like to add anything?
Nope, Dr.
Okay, so let's continue. So here we have done quite a few steps in preparing and exploring the data. So this is the summaries of what you have just done. So we have loaded data and then look at the data in the data table, and then choose the columns, classify and categorize the columns into targets and then features, and then use the plots, the diagrams to understand the problems better. Okay, so now we have done some more processing on the data. So as you have seen and you have known, in order to build machine learning model, sometimes we cannot work with the data directly because we need to transform the data into some types of data that the computer understands. So there is one reason that our computer is called a computer, because the computer does only one thing, that it does the best, which is to compute. And in order to compute, we need to transform the data into a kind of a number so that it can compute better. Okay. So if you look at our data here, let me show you back to the data. So if you look at this data, you see that there are some columns, for example, travel minutes and wake up times here. You see for the travel minute and wake up time, the wake up times, for example, it presents the data in the hour and the minutes formats. So which is understandable to us, but for the computer, it is very hard for the computer to understand because the computer simply adds things up. So if we would like to, our machine learning models to predict effectively, so we need to transform this data into a number, into real number, or into natural number that you have studied. For example, instead of presenting the wake up time as 6 hours 25 minutes, maybe we present that in 6.4 hours. So 6.4 is a real number. It is better for the machines to compute. Another example is instead of representing the day and the hour in the format 6 hours 30 minutes, we represent that in 6.5 hours. So this is the real number. It is the real number. So which is very easy for computers to done some calculations. Okay. And for the travel minutes here as well. So instead of presenting the travel minutes in minutes numbers here, we transform that into the hours representation so that these two values has the same units. And with the same units, the computer will compute and then calculate much faster. Okay, so let us try to transform these values into unified units. All right, so in summaries, we will transform travel minutes to travel hours and wake up time into wake up hours. In order to do that, we will use another widget called a formula here. As you see, formula here. All right, so now let us go to the details. So from the selected columns here, let us add some transformations. The simplest ways to do is to look at the transform here. We're still in the transform phase, and you will see the formula widgets here. So click on the formula widgets. You will have the formula here. All right. And then we draw a line from selected columns to formula. And then double click on the formula. So now it's give us the windows to define new columns or new variables. Okay, so we will choose the numeric, the types for the variables, the numerics or the number, and then we name that, for example, here, travel hour. All right. So for the travel hours, we will compute this travel hours from the travel minutes. All right. And to do so, you select the travel minutes right in the filter below it. And to transform the minutes to the hour, we just simply get the minutes and divide it by 60, right? Simple calculation is a little bit more work to do, but a simple calculation, right? Okay. And now let us check the results. So in order to check the result, we follow the same routine. We'll look at the result in the table. Now I double click the tables here. And you see we have a new column. Do you see the columns? Do you see the column there? All right, so now you have travel minutes and travel hours. So 42 minutes equals to 0.7 hour. All right, so now we can transform one columns to another column without changing the meaning. All right, so now we do another steps. The next step is to transform the wake up times to wake up hour. Wake up times to wake up hours. And as you see here, the wake up time and the wake up hours are in different data formats. So here we need to do some programming. But for today workshops, I will provide you the formulas here. Yeah, you just simply to copy this formula and paste that to the formula widgets, and it will translate the wake up times to wake up hour for you. Okay, so now let me post the formula there for you. Just wait a minute. Dr. Wang, could you help with the copy? Okay.
Yeah, sure. Yep.
Okay, I think I can do that. Okay, thank you. Okay, so now let me show you. All right, so now let us do another transformations. So now I'll go back into the formula again, double click that, and now we add a new variables. So this is also a numeric one. And here we would like to add wake up hours. Okay. And here, just simply copy and paste the formula that I share with you. All right. So this formula will translate the wake up times presented in hour and minutes into a single value, into a single real number, represent the hour. Okay, and just simply click send after you have pasted the formula there. And now let us check the data tables. So now if you check the data table, you will have another column, namely wake up hours. Okay, so 6 hours and 45 minutes equals to 6.75 hours. 7 hours 15 minutes equals to 7.25 hours. And this value is very easy for the computer to do the calculations. Okay, so have you done with this step, friends? Hey, are you tired? Yeah, so the processing takes a few times, but because we've done that with some explanations, it takes a few times. But if you done that independently, I think it takes you maybe just about 5 to 10 minutes. All right. Okay, so let us continue. All right, so this is the summaries of what we have done. And this is the result, what you have done. So now you have two extra columns, wake up hours and travel hours. And these two columns will be very powerful for the machine learning models to learn from your data. Okay. And now, since we already have the travel hour and the wake up hours, and these two variables or these two features are identical in meaning to the wake up time and travel minutes. So we no longer need the wake up times and travel minutes. So let us remove the wake up times and travel minutes out of the feature set so that our data is cleaner and is more and is tidier for the systems to learn. Okay, so reflections back from our learning. So whatever, if we have a ways to simplify our way of learning, for example, we do not need to learn as much detail, so just leave out the details. Just keep the core basics. Okay. So now let us put the wake up times and travel minutes away from our features. Okay. To do so, we apply the same routines. Okay. So here we apply the same routines. Here we, from the formula that we have here, okay, then we choose select column, and then from this column, see, you have travel hours here already. So let's remove travel minutes. So let's remove travel minutes from the features. You can click the travel minutes and drag it to the ignore. So for now, we ignore travel minutes. We do not need that features anymore because we have travel hours. And then we ignore wake up times. We do not need it anymore because we have wake up hours. So with that, it represents that when you have done machine learning model, given that you have the data sets, one of the crucial step you are doing is look at the columns of the data sets and then see whether those columns contribute to the predictions, whether those columns are useful and essential to the predictions. If it is not, make some transformation, for example, compute the new value out of that, and then look at the sets of columns again. If some columns are not necessary for the prediction model, simply ignore that or remove that from your features so that your data set is light and clean and tidy so that you can look at only the necessary thing that contributes the most to the prediction model in order to achieve your end goal. So if you can build a machine, if you can build a model and it is lightweight and it is tidy, so both of you and the machine understand that, and your prediction model will become much more effective. Okay. Right. So let us continue. All right. So next, we have everything we need for the data processing. So now let us move on to the third steps in to phase 2. So actually we have done phase 2. Now let us go to phase 3. So now given you have the end goals, you have the data, and you have pre-processed the data. So now we will train the machines. We will train the models. All right. And in machine learning, there are multiple types of ways to train a model. Such a way is called training algorithm. And so now we will apply some training algorithms in order to produce machine learning models. And as you see here from our steps that we have done so far, here you will see there are 2 more widgets that we have added here. And that widget is called tree and tree viewer. Actually, the training the training that we apply here, it is the technical term is called training algorithm. So have you ever heard of the word algorithm before? Algorithms is a set of steps to do something to produce an end result. And in machine learning, such algorithm is called training algorithms. The result of training algorithm is a model, a prediction model, a machine learning model. And amongst many training algorithms, we choose one of the most popular but yet effective. It is called a decision tree. Okay, and after you have done the training, you will have a tree like this. So now let us apply the training first. Okay. Now let us go back to the step we have done so far. Right. So what you have seen here and what we have done so far, this whole set is called workflow. Yeah, this is the technical term. It's called a workflow, and later on you will use this workflow in the projects that we will introduce you at the end of this workshop. Okay, so now we will add one more step to the workflow. In this step, we will add the training algorithms. All right. So given you have the steps so far here, then from the latest steps, we add the data table so that we can see the data in the table format. And then let us look at the model here on the left-hand side pane. And then in this model, you can choose the tree here. Okay, the tree here. Please click on the tree. And then draw a line from the data table here, the latest data table, and draw a line from the left edge to the tree. It represents that. So now, given the data we have prepared, now let's input this data into a training algorithm, which is the decision tree. Okay, and then click on the trees here. You will have a few settings. For example, whether you want the trees to be just 2 branches already or multiple branch, and the accuracies of the decision tree here. For the sake of this workshop, if you look at the parameters here, I encourage you to uncheck under the parameters here so that you can see the full tree. Maybe on your machine, it appears like this. So I would like you to uncheck that, uncheck, 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 and uncheck, so that the tree will explore its own possibilities. All right. So now you have configure, you have adjust your tree. Now let us look at the result. And to do so, we will use a widget called tree viewer to view the tree in a visual kind of way. Okay. So now to do so, click on the left edge here, and the right edge here, sorry, drag it, and then choose tree viewer. Right? Now double click on that. You will see a decision tree. Why it is called the decision tree? Because if you look at this tree here, you can make the predictions. You can decide whether you probably be late for school or not. Okay, and as you see here, this training algorithm will look at the data sets, and then it will choose the features that help us to structure, to classify the data, to make a determinations. And you see that among those features, the travel hours, the one that you have just built, is one of the most classifying features of all. For example, if you look at the travels here, you can predict whether you might be late for school or not. For example, if the travel hours is less than 0.5, which means less than half an hour, so you will not be late for school. Okay, if it is more than 7.5, then you might be late for school or might not be late for school. It cannot conclude yes. So you need to look at another feature, for example, wake up times, wake up hours. Okay. So if the wake up hours is more than 6.9 hours, which means that if you wake up at around 6:50 or 6:55, then might be you will be late for school. And if you wake up maybe earlier to 6:45, then it depends on the day that you travel to school. Okay, if you travel on Monday, then you will not be late for school. If you travel on Wednesday, you might be late for school. Okay, so when you look at this table, and given the data, given the travel hours, the wake up hours, the days, then you can make a prediction whether you will be late for school. All right. So have you reached at these steps? Have you reached these steps? Any questions? Okay, so far you have built a machine learning models, which helps you to predict whether you might be late for school based on the history data, your history data. All right, so recall, this is called a training algorithm. Yeah, and this is called the model. Okay, so after you have developed machine learning models, and you did, now let us check the accuracies of the models. So in order to check the accuracies of the models, we will use two more widgets, and namely the test and score and the confusion matrix. Okay, so now let us do these steps. Okay, so in order to do that, from the trees here, you can draw a line here and then add the test and score. Okay, so test and score is the widgets to check the accuracies of the model. And with that, you also need to draw one line from the data, okay, into the test and score. It means that now we test the accuracy of this model given this data. Okay, and then one more steps, you add the confusion matrix here. All right, so now let me explain it to you. So now when you click on the test and score here, you will see several numbers here. All right, and when you click on the confusion matrix, you also see some number here. So let me bring these numbers up. All right, so this number tells you how accurate your machine learning models is. So now let us look at the confusion matrix first. So the confusion matrix this is a matrix. It shows you how accuracy your model predicts the data. And you see there are two columns here, the predicted one and the actual one. And as you recall, we have 60 rows in our data set. So this is 60 rows. And out of those 60 rows, you have 35 cases, 35 rows not being late to school, and 25 rows being late to school. Okay. And here you see that we have the actual late or not late and the predicted late or not late. And as you see here, our model is very good. For example, in 35 cases of being late, not being late to school, so our prediction model accurately predict 34 out of 35, which is very good. Okay, and among 23 cases of being late to school, our model predicts 23 cases correctly, only 2 cases wrong. Okay, this is quite good. And now let us look at the test and score results here. So there are multiple numbers here, but I would like you to pay attention to only one. The second one, the CAs here. Okay, so the CAs here stands for classification accuracy. So which means that the accuracy is a prediction. And the number is 0.95, which means that our accuracy is 95%, which is very good. So out of 100 cases, 95%, 95 cases are correctly predicted. So it is very good one. Okay, so given our data set, then the training model gives a very good result. Right, so some summary. Okay, so far, any questions? All right, so if you have followed us until these steps, congratulations, you have completed the basic workflows of building a machine learning model. So actually now, your current workflows here is a machine learning models. So we start from the data, and then we explore the data here. And then from the data, we select the columns to categorize the columns into classes, targets or labels, and features. And then we look at the data in visual presentation in order to understand the data more. And then we transform the columns, the features. For example, we build new features that are more useful for the calculations to build machine learning model, and we remove the features that does not contribute much to the machine learning, to the building of the machine learning models. And after that, we train the model by using specific training algorithms. So here we use the tree and the decision trees in order to train the algorithm, in order to train the model. And we actually have the model, and then we test the accuracy of the model. So now given we have the model, so now let's apply. Let's use this model on the new data. So let's say now you have the model and then you have some new data here. So now let us answer the questions. So given this current incidents, given this current conditions, whether I might be late to school on the upcoming Monday if I wake up at 6:45 and the travel minutes to school is 30 minutes. And given that the weather is sunny, the traffic is light, and I will not sleep late the day before, and I prepare my bed in advance. So whether I'm late to school or not. Okay, so now let us apply. Let us try to make predictions. Okay, so now let me show you several more steps. Now, given the workflow that we have like this, now in order to make predictions, we follow the next routine. So firstly, we just follow the same routines. Firstly, we load the data, okay, by using the file and the data table widgets. Okay, let's do it together. Firstly, let me give you the data set first. 20 minutes. So this is the data set to make prediction. Okay, so now could you help me to load this data set into Orange? Okay, so do it quickly. Firstly, I use the file widgets. Okay, and then I copy the data set. It is here. This is the data set. And then I look at the data sets. All right, so this is my data sets. So you have already loaded the data sets, haven't you? As you see here, we have the same number of columns, but the latest column is question mark only. We do not know whether we're late or not, right? So now our job is to fill the late cells here with yes or no, and we will let the machine learning model to do that for us. All right, so now to do so, you add another widget called prediction. So now we want to predict this data. Okay. So now let's do so. From the file here, click on the right edge, drag, and then choose prediction. Right, prediction. And then with the predictions, now you can click on the predictions to see the results. Click here to see the result. And what does the result contains on the latest column? It's still question mark. Why? We want to make a prediction, but why it is still question mark here? Okay, so although we did choose making prediction, but the prediction seems not done yet. And this is because the program does not know what model is used to make a prediction. You see that? Here, between the models you have built and the prediction, there is a gap here. It does not know. Okay, so now we instruct the computer which model is used. To do so, we just simply draw a line to connect from the trees here to the predictions. Okay, to tell the machine that we want you to use the models that I have built. Okay, so now let's do it. To do so, just simply draw a line here. Be sure to draw from the right-hand side, not the left-hand side. Okay, and plug it right here. And now when you double click, you will see. Now it helps you to predict. Okay, and could you have me check whether the prediction is correct? So this is the data that the machine does not see before, have not seen before, and now you use it to make a prediction. Okay, so have you done these steps? Okay, thank you very much for confirming, friends. All right, so you can check that against the decision tree, and then you can confirm that whether it is correct or not. So this slide is also the whole workflow that you have done so far in the last 1 hour. This is quite a long time. So now I give you sometimes to contemplate, and then the next part is for you to practice the machine learning on the new data sets. Okay, Dr. Wang, let us take a 5 minutes breaks before students continues with their own practice.
Sorry, Dr. You mean that we take some time for students to break a few minutes?
Yeah, just let us take 5 minute breaks because they have followed for nearly 1 hour and a half.
Yeah.
Okay, so friends, let us take a 5 minute breaks, and let's come back to the workshops at 3:37. Okay, and then you practice, and we will support and facilitate. Okay, let's have a short break.
Okay, thank you, Dr. Trung. So while we have break time for the student, if you have any question at the meantime, I can also help you with that. I can see a few questions in the Q&A chat. One from Cole, and I already put the answer there. Cole asking about what is the meter column? That is first types of column in the dataset. So you have learned from Dr. Chung lectures that we have two main types, the features, the label. So the features is the input for your model, and the labels is the output. And meters is something that is not to use as the input or the output for the model. Okay, it is there, it's for other purpose, but it's not for input or output of the model. Let's say you have in your dataset the student ID or the student name, you don't use it for the model, but it's there to identify the student. Okay, so we call that the meter column. And I think I have another questions from Ngân, looking for teammate. Okay, so she's asking for the teammate. So if you want, you can comment below her post to join her. Okay. Thanks, Ngân. Let's see if is there any other questions. Okay.
Okay, let's take some rest, friends, and after that, you can go back with the practice. Okay, stand up, stretch your legs, have some water, and then get back in 3 minutes. So friends, are machine learning's easy to do? Is it complicated? So if you have any questions, concerns, or interest, and your experiences before when you learn programming at school, somehow relates to machine learning, feel free to share with us.
I don't. So a student asked to share the slide. Is that on the workshop folder already, or now we can share the link here?
Ah, yes, and let us share. Let me share the links to you.
So here, Khoi, he has follow-up questions. What is the difference between the meter columns and the ignore columns? So ignore column is something that we totally not using at all, Khoi. But the meter one, even we not using for the training, it still have its meaning there. Let's say the student ID and the student name, we don't use it for training. Just like ignore, we don't use it for training, but it has some meaning. Later on, if you want to identify the student, then we use a student ID, right? But for the column we ignore, we don't need it anymore. Okay, it can, totally delete it out of the dataset, and we don't lose anything. Okay, we can totally remove it. Okay, so I hope that's clarify your questions. Feel free to to continue if you have other concern. Okay, I think now you can answer.
Yeah, so now let us resume to our workshop. Firstly, I will share the
So, Dr. Tung, will we continue? So we have a few minutes to answer the question from the students.
Yeah, so firstly, I have shared the links to the slides. Could you check whether you can access and see the results? Okay, so now you have graphed the overview of machine learning workflow in Orange data mining tools. So now let us practice. Practice makes perfect. Let us practice to distill the contents and also experience the machine learning procedures for yourself. Dr. Wang Din Bao have a question. Why, after moving wake up times and travel minutes from feature size to ignore sign, the formula notify me that wake up times and travel minutes, there are some errors in wake up times and travel minutes.
Okay, so thanks, Dan Bao. Please double check that the flow is in the correct order. So
Yeah.
you can double check this from the slide. The order is important. So if you ignore it before you do the computation, I mean, before you put the formula, then it can give you the error. You need to put it after that. Okay.
Yes, but as Dr. Wang has shared with you, it is just simply that, for example, when you remove the features, and after that, in some widgets, you use the feature because the feature simply is not there, so the program cannot recognize that. Okay, before you work with the specific features, make sure that it is there. Okay.
And
Thank you.
I think we have another question from Nguyễn Phú Nghĩa, Dr. Trung. So, yeah.
Nghĩa asks, I have a question. Projects requires real evidence. Yes, Nghĩa. So you can, for the project, you can collect the data. If your data is real, then the machine learning will produce realistic answers, realistic predictions. If your data is not real, for example, just for if you build the data for practice and exercise purpose, you can still build the machine learning model, but because the machine learning model learned from something that is not real, it cannot produce a practical answer. Okay, although it can produce some answer that looks meaningful, but because it does not relate to the reality. Okay, so I encourage you to collect real data. Okay, does that answer your question, Nghĩa?
Okay, and I can see in the meeting chat, Kang asked a question that is there any machine learning applications that can boost his study? I don't know. I don't know. Yeah.
Thank you very much,
Yeah.
Ken. I think the real elements that can push your study is human learning. You are the agents that push your study. This is better. The machine learning can help you, can facilitate you to study. Yeah. Okay, so while we answer question, we also move on with the practice so that we can do that at the same times. All right, so with that, the workflow about machine learning, so now I would like you to build a machine learning model that have you and help us, help me as well to make a decision about this everyday life decision. Should I drink a glass of milk tea today? Okay. So, and we follow the steps that Dr. Wang has shared with us, the 4 phases in machine learning. First, phase 1. So as you recall, phase 1 is very important because it is the directions. This is the end goal that determines the purpose of the machine learning model that we are building. So for phase 1, we answer the questions, the end goals, and whether there are any existing solutions out there, and the data that we need to have or collect in order to solve these problems. So for this phase, so it relates to the topics that we have shared before with the topics for this practice. So should I drink a glass of milk tea today? And in order to do so, I need some data, and this is the data that we provide you. So this is the realistic data, but not from real fact yet. So we synthesize those data for the practice purpose, but it also looks realistic. For example, in order to determine whether today we should drink milk tea or not, so we base on quite a few features or quite a few data. For example, the current times, the current time and the money available, the drink price, the time we need to waste at the queues, the weather, and the level of sugar we have digested today already. And the third level, dinners, and the dinner times, and then friends, whether we have friends by that person. Then based on those data, we make a decision whether we should drink a milk tea today. Okay, so I give you this data, and then could you go through the steps that we have done before in order to build a machine learning model? Okay, so firstly, please check the data, whether you can open that, and you can open and read that. Let me post the data. Let me post the data links to our meeting. Okay, so have you seen the data posted on the Q&A section? Can you access the data? All right, very good. So now I give the time back to you to practice, okay? So you can share on the chat, or you can note that on your notebooks. So given the data, what is the label in these data sets? How many samples are there? How many features are there? And then after that, you can consider process the data by creating new features, ignoring some features. Okay. So to facilitate your work, I bring back the whole workflow here. So to recall, so this is called the workflow. Yeah, this is called the workflow. The flow of work from the loading of the files to exploring, preparing, and processing the data to building the models and then test the model and then applies to my prediction. So when you have finished, could you copy your results and then paste it on the chat on the Q&A so that we can see it together? Dr. Wang, would you like to facilitate or anything that you would like to remind students during the practice?
I think all good so far, Dr. Tung.
Okay, thank you, Dr. Wang. Okay, let me open the clock. Let us spend 20 minutes. So during your practice, if you have any difficulties, anything you would like to ask, feel free to let us know. Is 20 minutes enough for you? Very good. So when you walk through each steps, please recall yourselves of the knowledge we have learned so far. I do not consider this as a teaching. I just consider it as a sharing with you. Yeah. We share with you what we know, and then we learn from you what you have exploited from the tools. All right, so which phase are you in right now? If you reach the middle of the workflow, very good. Very good, very good. Have you studied any programming at school? If you study Pascal or Python's programming at school? Very good. Oh, it's amazing, Phương Linh. Yes, please. So have you seen the presentation slide, the link to the slide? You check. Okay. Here, I resent to you the link to the slide. Could you check whether you can access the slide shared? Thank you. How many programming languages have you known so far? I've seen some friends here mentions Python. I think Python is popular among you. HTML and Python. Yeah, don't worry, Phương Linh, the advanced is built upon the basic one. Yeah, C++ is a powerful one.
I saw a question from the Q&A section.
Let me check. Thank you, Dr. Wayne. From Minh. So Minh, could you say that in more details? Minh asks, can you show the requirement again? So about the projects, let me show you. here's the end goal. Okay, this is the end goal. So given the data, and now imagine that today is Wednesday, and you advise to you actually whether you should drink a glass of milk tea today. Okay, and in order to do that, you have like a milk tea drinking history that you have recorded in your diagram in your diary in the last 100 days. Then based on that, you use that to make a decision whether you drink a glass of milk tea today. Okay. And the data that you have here is that diagram. And then because there are so many factors, so many variables on which you use to make a decision. So you ask the machine to give you some suggestions based on the real data. So that is why you build the data. Okay. Then you build the model. So the requirement is this. The requirement is based on these pieces of data, of information, make a decision whether you drink a milk tea today. Or you predict the last columns here, drink milk tea today. Did that answer your question, Min? Dr. Wang, I see several friends here have studied a lot of programming languages. So they have studied Python and C++, Java. All right, so in the models, you see the system tree is just one of the training algorithms. There are quite a few algorithms there that we do not have enough time to cover, but they share kind of similar patterns. Okay. We have a friend ask about the scatter plots, about the x-axis and the y-axis in the scatter plot. So actually, the scatter plot is like the coordinate of the scatter plot is like the OXIs, OXI coordinations that you have studied in high school. So it shows the relationship between two variables. So have you recalled the functions y equal f of x at school? So y equal f of x at school shows you the relationship between two values, between x and y. So this scatter plot is the scatter plot is about the relationship between two axes as the x equal f of y equal f of x that you have studied at school. Okay, so among a lot of features here, it shows you the relationship between two of those features. Yeah, for example, between wake up times and travel times. Okay, and those relationships give you some information about the targets. Okay, for example, if you wake up at a certain time and you travel at a certain duration, is it likely that you will be late for school or early to school, not on time? Dr. Wang, as some friends have questioned with the formula, could you help?
Yeah, sure. You mean in the chat, right?
Yes.
Okay. Getting 79% of the model. Getting 79% of the. And I'm not really guess your question. Could you please that again? Okay, attention. Trouble formula. I don't know how to change current time to int. Okay, so for that, you need to write the formula in Python. That requires some Python skill. I'm afraid. Okay, so if you know, otherwise you can have some way around. Start at the formula section. What is the formula variable for this? Okay, so in this one, I believe that Dr. Tuấn make is open for you, so you are freely to process the data. And in real project, it's like that. There are many ways to process the data, and you make the better the data, then you can get the better performance. So it's like try and error process. You may try with one way, and if it's not work well, then you can change it. Okay, so it's really open. It's really up to you. We don't have a unique answer. Okay, the formula, the variable to transform, that's totally up to you. You can try around and see which one will give you the best. Getting some simple model. I'm not sure what is the percentage there, Dr. Tung, when the student asked me about that.
Since that the machines and their machine learning models has 70% of accuracy, is it good enough? So could you have some ways to, continue?
Yeah, so that's mean they can achieve that 70% of accuracy, right? And so you can see here, even you are given the same data set, a student can get 79% and another student 70%. So it depends on the way you process your data. Like we gave you 10, for example, 10 column, but you don't need to use them all. You can use just 7 columns, select the column, and it can give you the better performance. Or you can do some transformation instead of using original data set. You can transform some column to get some new column, and this can provide you better performance. And in addition, selecting, good model, suitable model for your data set is also contribute to performance improvement. Okay, so you want to improve, you need to try around. In this one, focus on 2 things. The first one, how you process your data. And the second one, which model you use to train. Okay, so in the table, we use the decision tree, right? But you can use other one like random forest, SVM, or the model. Try them out to see if they can boost the performance. Okay. Oh, I think Howard try to answer the student questions. Okay. Oh yeah. Yeah, I totally understand. This is yeah, but you haven't practiced Python. Yeah, it's totally fine. You can find just some simple transformation at the moment. When we need to really improve the performance, then we need some advanced formula, and this require Python. But with the AI chatbot nowadays, quite also it's make it very easy to use. But I not really recommend it before you study Python, because if you put the prompt for the chatbot to generate the Python code for you, it can eliminate your motivation to study Python. It is not good. You can achieve something, but you need to pay quite expensive that you may lose your motivation to learn Python. It's not good. Yeah, but at the moment, if you want, you can do some instance try, but do not really rely on that to write Python code. You should learn it yourself. Okay, should I change the model? You mean changing from one model to another model? Yeah, of course. You can try many different models is listed out there. SVM, random forest, and logistic regression is totally up to you. You can try them on to see which one working best. Because in the train, yeah, that's the issue with data type. You let me see, this is the me. Okay, it's a tree. Okay. Oh,
yeah.
Yeah, you can could you please send that to
So you see that although the flow is quite simple, yeah, but the processing of data, as Dr. Wang shared with you, is quite complex. So it depends on the data set. And you see that you are, I compliment that you see the need for transforming data from one forms to another, and you see the target there. And we face some challenges in applying some calculations or operation to transform data We also have the same difficulties as well. Yeah, and I think that the points that you recognize the need for changing is a really important takeaway from today's workshops.
Thanks, Dr. Trung. And I think the question from Hải Nam Lion, right? I guess. So you mean that you are trying the demo data set, right? And it's not work for you, right? So like, did you, when you import the data set, you use the URL or you download it? If you download it, make sure that you save it in CSV, okay? Because if you save it in Excel, maybe it will transform the data type to string or something, and that it doesn't work right. I think the best way to practice here to use the dataset from the URL. Okay, so you don't need to modify any data type there, because I can see that other student, it is work for other student. Yeah, you can try with the URL. Because when you download it, it can change the data type of the column. Hey, welcome.
So now let me try to do some. So there are some ways that can help you with the data sets. For example, now let me try to create a new flow here. Okay. And now let me follow the steps. Okay, so now let me try open the practice data sets. Here's one more steps that you can do. For example, here in the loading of the data set, you see in the panes below here, it shows you the structure, the column structure, and it shows you the types for each column. So from here, you can also change the data types. Okay. Let's say you have drink price here. So it is already in the numeric, but in case this is in text, so and you determine that it is numeric, you can change the data types here. So it somehow helps you. It cannot solve all of the problems, but it somehow helps you some way. If the data here are recognized in a certain data types, and it can be transformed into target data types, then you can also changes somewhere here. And for the data type that it cannot be converted here. So usually you need to apply some Python programming, particularly translating data from text to other data types. Okay, and with that you can refer to some instructions on Python. So I really want that I can cover all of them to you, but because of the time limit, if you face such difficulties during your project, feel free to share with us and we will help you. All right, and so with I assume that by now you have completed the second model, and when you have completed the model, you can click. You can save the model. Yeah, for example, here you have completed one flow. Here you can click a file and then save the model. Okay, And then you name that. For example, here I will save this model, my first ML model. Save it. And then what you save is a workflow. So it is called a orange workflow. Okay, and this workflow is actually your home process of making a machine learning model, and then you can send these workflows to your friends or to your colleagues or to an organizations. For example, in these workshops, after that you work on a project, you can save this workflow. And this workflow is actually the steps that we need in order to see the model you have built. Okay. All right, so any question related to the workflow that we have done so far? So with that, we would like to go to the summary, and then we would like to share with you the projects. Okay, so for summary, as you see, machine learning is to learn in a way that a machine or a computer learns. So back to the question that I'm asking you, that I asked you in the beginning, what is machine learning? So could you share with me your answers? What is machine learning? So here, my definition is machine learning is to learn in a way that a machine learns. So it sounds obvious, right? What is the difference between machine learning and human learning? Is there any difference between the way the machine learns and the way we learn? Any sharing? Okay, let me go ahead and share with you our understanding. So the way machine learn is several steps that you have see. Firstly, machines look at the data and then it links the data together, particularly the features and the labels. And then it digests examples we provide. And after that, it makes predictions on the labels from a new data that the machine has not yet seen before. Okay, so for machine learning, the step is very simple, and the tricky parts or the challenging parts is the processings that you have seen so far. For example, translating data from one types to another, or recognizing the data types of some features and then convert that data types to specific types that can be processed. Right? And with that, with such simple steps, we can build machine learning models that are useful in everyday life and can also support the advancements of science. For example, we can build machine learning models to help us answer a simple question like this: what might the weather be like in August, given the history data? Or even a little bit more complex, but more useful, like predicting whether an organ donor and the receivers are compatible. So it is very crucial and essential importance in medical field, or which combinations of elements that might create materials that is light but can still resist high heat. So this is very important when you when machine learning is used to build material for spacecraft or for aircraft. Okay, and with that, we would like to conclude the workshops, and we hope that for the steps that we have shared with you, we have somehow introduced you to the field of machine learning, and you can see that with the computers, we can build useful models programs that can help us not just in a sophisticated project, but in everyday life. Okay, and with that, let us introduce you to projects that you can use to learn machine learning and also to build some products for this workshop and for the RMIT TechScam programs. All right, so let us go to the projects. So in the upcoming projects, we think of something that relates to the current phenomenon, which is the AI. And we would like you to use machine learning in order to address those specific topics. And the topic we would like we give to you is this: predicting independent language expression using AI usage habits. So recently, AI is a phenomenon, and almost all of us knows and use AIs, particularly generative AIs. So as this morning, Dr. Ling has shared with you a varieties of AI's tools and also different techniques to use AI. There are pros and cons of using AI. For example, when you use AI, it enhances the way we work and it speeds up the process of work. But on the other side, it also affects our cognitive performance, the way we think and the speed of we think, and somehow it affects the way we use language. So if you reflect on your own everyday life of using AI, maybe you can see that because AI help us to generate a lot of text or a lot of language. So somehow our level of using language is decreased when we use AI quite a lot. So today we would like to share with you a topics to predict whether using AI affects our language expressions or not. Okay. All right. So in these projects, what we do is to build a machine learning model in Orange data mining tool to predict whether a student's independent writing ability is high, a medium, or low based on their AI usage habits. And so in order to do that, we need to have some data. And you can collect data about how often students use AI, student or pupils use AI, and how they use AI, for example, whether they copy answers, edit outputs, write drafts, read, or practice writing with AI. And the step is that, for example, you designs and collects data. And the data can be 30 to 50 rows, but I think if you can collect more data, the more data, the better. Okay. And you load the data set into Orange, and then with that you analyze and process the data, choose the features and the target, and then train models. So here we mentioned decision tree, but you can do some own research, and then you can choose other training algorithm that you see produce the better results. And then you evaluate the score. You evaluate the accuracy by test score and confusion matrix that we have shared with you. Or you can also explore the Orange data mining and suggest other techniques, other tools in order to evaluate the accuracies. Then you present the findings and have some reflections on your projects. And here is the links to the detailed description of the project. So you can scan the QR codes here, go to the links to know more about the projects. Okay, Dr. Wang, would you like to share the details of the projects?
Yes, thanks, Dr. Tung. So can I share the screen, or you please share the us?
Yes, let me go to the link. Just wait a minute, Dr. Wang.
Yes, sure. Otherwise, let me share my screen.
Okay, please share your screen. I think this is better. Thank
Okay.
you.
Share my screen now. Okay, so here is the project for this from this workshop is about machine learning. And the topic you have already heard from Dr. Trung, that's predicting the language expression skill from people based on their AI usage habits. Why do we have this one? Because nowadays there are research tell us that the usage of AI is really impact on our language expressions. Let's say if we can point it out from machine learning. Yeah, and this project is only for learning purpose. It's not to discriminate your friends or anyone about their ability. Okay. So here is the overview. You can see all the detail on the file given to you. And in this one, you will use this is a requirement. You need to use orange data mining. So it's make it fair for all the team. And this is the goal to predict the ability to express the idea, okay, based on their AI usage habit. And what are the AI usage habits? So you can define that using multiple types of features, like how many times they use a week. So this is one column you can collect data to, or what is for whether they have independent thinking before asking AI and so on. So these are suggestions, some suggested features. You don't need to feature this one, but it's some starting point for you. And for the results, you should do some classification that output some class like high, medium, low, or good average SNP improvements. They actually three values, 1, 2, 3. And here is the detailed project requirement. And here is actually just a step you have seen in the demo. You need to go through 4 steps. You find or collect the data, and then you explore and prepare the data. You process the data, and next you will create a prediction model using the orange, and then you evaluate the model. Also use the orange one. And below that, we also have a lot of details about how you can collect or build your own data set. So it depends if you can find from some source online, or you can collect yourself, but it's almost impossible for the time limit. You need to have the data set. You can collect it somewhere, get it online, or you can even generate it, okay, simulate the data set as well, okay, for learning purpose. This is acceptable. Here's some requirement that you have at least 200 rows for the data. And here, similar to the poll park, we have some suggested feature for you. But you doesn't need to stick to this one 100%. You can consider this one as suggestions, like AI use frequency. This is the meaning. This is the output value. And when you have your own data set, you also should have similar table like this one to describe your data set. That's very important, because when you release your data set, someone, when you use it, they need to understand it. And this information is, extremely important for the one who decide to use your data set or not. You need to clearly describe, at least like this table, the column name, the meaning, and the value in that table. Besides that, we have also some other description. You can search online. The dataset they given online, like in the Kaggle or some repository. You can see how they describe the dataset out there. How they describe it. And you also, so this is for your team selections. So this is the dataset, right? But which column will be your label? You will decide yourself. Okay. This one is independent from the dataset itself, because for all the team, all the people, they can use the same data set, but they do for different problem, different end goal. So they can define different target or different label. But this one, you will tell that your team select that one. Okay. And this is the example. And the tool to use is the orange. And here we just, uh, you know, summarize the step for your convenience here. And for submissions, here the instruction, you need to zip or you need to, compress on the file and you upload it somewhere. Okay. Do not submit it directly to the file. You upload it somewhere using like some cloud, OneDrive, Dropbox, Google Drive, or anything. And then you share the link. Make sure that that link can be accessed by us. Okay. I think it's best to share like anonymously that anyone have the link and access. Otherwise, when you click on that, we can read your file. Okay. You upload everything in one zip file and then you share the link. You submit the link in this form. Okay, this form from the organizer. You need to submit it there, and then you can see it. Okay, and what you need to submit in this project, you need to submit three things. The first one, that is one by poster. So consider this one like infographic, the poster to communicate with the audience all the thing about your project. What is your data set and how you build the model, how you verify, how you test your model, and what the meaning, what insight you get from this one, and even some reflection if you do have. Okay, make it a poster. Okay, attractive poster to the audience. And if you like you winning some award later, this poster can also be used in a showcase. Okay, and beside so the poster is show all the result your team get. Beside that, you also need to submit the data set. So this is the data your team create or collect or find somewhere on the internet, but you actually use it in your training model. So you submit that file in CSV to be consistent with all the team. You submit in the CSV one. Okay, and you also submit the workflow. Okay, so we have, if we want to re-evaluate your model, like you report here in the poster, very good performance. If we want to check it, then we have the data and we also have the workflow from your audience. Then we can import the data into your submitted workflow, and then we can evaluate the model. You can see the model work again. Okay, so that's all the thing you need to submit. And here we also have the evaluation rubrics. You can check it out to see how we evaluate your work. So we have here three criterion for the poster, for the CSV dataset, and for the orange workflow. For each of the criteria here, we have some sub-criterion as well. And we also have the range range here. You can see, I think it's quite detailed. Yeah, check it out. Okay, so that's about the project. Let us know if you have any questions. Thank you. Okay, Dr. Tuấn, do you have any add-on to student?
Yeah, it is very clear, Dr. Wang. So friends, any questions and concerns about the projects? Who has a question?
Okay, so Dr. Tung and Dr. Wang, thank you very much for your very engaging and fun workshop for machine learning. So finally, you guys know exactly what is machine learning now, and you guys actually perfect now. All right, so let me quickly share my screen and then we talk about some of the stuff, important stuff. That all right, so let me quickly go through the timeline again for the whole program. So we are in the phase one right now. We have 2 days of workshop. So we already finishing the first day of workshop. We could still have workshop tomorrow for another 2 additional topics. On the next day, which is the following day on Wednesday, right? So we're gonna releasing all the topics exactly at 10 a.m. And then you guys start to working on the projects. Keep in mind that all the team need to register for the group projects, right? So I already posted the chat and also the link here. I think we already provide you the link to register for the group projects. Was in the chat as well. So make sure that you have at least 4 members to sign up for the groups. And the deadline for the group registration will be 5 p.m. on Wednesday. So going to be on the 12th June. Okay. Um, we actually need you guys to submit this form. Why? Because in the form, we actually require you to submit the consent form, right? Because all the team, when you guys, if you guys actually winning, we're gonna invite you to RMIT campus, right? Because you guys actually high school student, and we do require your parent permissions. So in that specific form, you're gonna have the consent form. You have to fill this consent form so that it can allow you to travel to the RMIT campus, all right, without your parent supervisions. I think it's quite important for that. So if you already have a team, that's awesome. Please sign up for the team registrations. If you don't have a team, please, go around, talk to people, try to make friends and try to form a team. Okay. It's gonna be awesome. So keep in mind that we have another 2 workshop for tomorrow. So we have the cybersecurity workshop in the morning and the Arduino embedded system in the afternoon, right? So that in total gonna give you 4 different topics, right? And that we're gonna provide you 4 different project topic as well, right? That's gonna be aligned very well for each of the workshop topic, and your team will make a decision like what topic that really align with you, like what actually make you feel alive, you choosing that topic and you work for that specific topic. And let me go back to the timeline again. Right, so you're gonna work for exactly 1 week. The deadline for the group registrations, sorry, submission gonna be on the 17th of June. So give us a few days to marking it, and on the 20th or 22nd of June, we're gonna announcing the winners. Right, we're gonna reach out to the winning team. In Saigon, we're gonna in Hanoi also selecting 10 team in Saigon and 10 team in Hanoi, and we're gonna officially invite you, roughly 40 students, all right, from each campus to our RMIT campus, to pitching for your projects. And then also we have some exclusive benefit there. Right? We have the in-person workshop where you can build robots, like robot cars. You can design, assemble your robot cars. You can build your whole AI system there. We also have Ray food there at RMIT. I can promise you we have Ray food at RMIT, right? Yeah, so that's a lot benefit. So, since you already joined the workshop, I think it's actually worth it for you to also working on toward the project as well, right? Apply what you learn and create cool stuff. And we love to see that. Okay. Um, and check your email and your Facebook page, very important. Okay. I think that's all the time we have for today. Before you leave, please provide us amazing feedback, right, to Dr. Lin, to Dr. Tung and Dr. Wang here, right? So they spend 3 hours working hard to teach you guys machine learning. I think we deserve some positive feedback. Okay, so please take your 2 minutes of your time, please scan the QR code and please fill in the love, right, in the form for us. We want to see those amazing feedback from you guys, okay? I think it's very important that that's encourage us and make us sleep really well at night, okay?
Yeah.
All right. Please,
Thank you,
2 minutes.
thank you, Mr. Toms, for your nice work. And thank you, friends, for joining with us in the 3 hours to walk through the challenge, and also learn and share, and also share with us your difficulties and also your interests. So we are really we enjoy to have you in these workshops, and we hope that this workshop is just the beginning, and it will have you see the interest and the joy in learning, and especially using ITs and computer science for meaningful work in life. Thank you very much.
That's right. Yep. Dr. Wan, do you have any saying, anything to?
Yeah, want to say thank you so much to Tom and all the organizer. Thank you, Dr. Trung, and thank you all the students here to join us. Thank you very much. And I really hope that we may have some chance in the future to meet and to work or have such some time to hang around with each other. Okay, thank you very much. See you sometime.
Yeah. Oh, and one more thing. Thank you very much, friends who volunteers to have us in the RMIT text camp here. Thank you for your times and your effort.
Thank you very much. Remember, we still have workshop tomorrow, so don't skip it. You haven't seen the best of it yet. We still have a lot of things to show you, amazing thing to show you. Please don't skip it. Please attend the workshop tomorrow, and try to sleep tonight and then think about what kind of teammate do I want my team, and go and find your teammate. You can register for a team, and we're gonna see you again, hopefully in the grand final, right? We're gonna invite you to workshop and see each other in person. It'll be fun. All right, thank you guys. I think I'm gonna leave now before we have a traffic jams. Okay, bye bye. See ya.